What's up, guys? Today I'm going to go through a hackering challenge. I have no idea what this is about. This is a part of a continuation that I've been solving through. So this is what I landed on today. So this is about apple and oranges. So let's go through it together and let's see how long it takes for me to solve this one. So it's about the problem is, let's see. So Sam's house has an apple tree and an orange tree that yield an abundance of fruit. Using the information given below, determine the number of apples and oranges that land on Sam's house. Okay, so we have a diagram. In the diagram below, the red region denotes the house, where S is the start point and T is the end point. Okay, so S is the start point and T is the end point for Sam's house, basically. Okay, and assume the trees are located on a single point where the apple tree is at point A and the orange tree is at point B. So if we look at the diagram here, can we oh no, we cannot minimize this, the editor anyway. And so here is the full diagram here. So apple tree is on the left of the house here. So this is the Sam's house. We have A, it's a stable point, of course, it's a tree. Duh. We have apple tree on the left of Sam's house and orange tree on the right of Sam's house. And okay, A and B, apple and orange. Okay, B. When a fruit falls from its tree, it lands d units of distance from its tree of origin along the x-axis. Okay, so when a fruit falls from its tree, whether it's apple or oranges, it lands d unit of fruit on Sam's region. Okay, a negative value of d means the fruit fell d units to the trees left, and a positive value of d means it falls d units to the tree's right. So if that is the case, so the unit, this d is a negative value, it will be on the left of the, it will fall on the left of the tree. And if it falls, if it is positive, it falls to the right of the tree. Okay, is it so? Let me kind of understand it again. Units of this negative value of d means the fruit fell d units to the tree's left. So if it is, so let's say A, and it falls, it is we got some negative value, so it will be to the left of the tree. So that won't be to the Sam's house. Basically, okay, let's say that, and if it is positive, it kind of goes to the Sam's region, something like that. Okay, it's still theory, and the same goes for this. So if for oranges, if it is a positive value, it falls to the right, isn't it? Yeah, negative value d means, oh, it's the same anyway. So positive means to the right, negative to the left. So whether it's A or B, oranges, apples, or pineapple, whatever it is, negative is equal to the left. So for oranges, if it is a negative value, that means it's kind of like going towards the Sam's place. And to the right, it's absolutely no idea where it's going, nowhere, basically in the nowhere, no man's land. Okay, let's scroll down. Okay, we have some examples here. Exactly what I needed. Okay, given the value of d for apples and n oranges. Determine how many apples and oranges will fall on Sam's house. Okay, inclusive range S and T. Okay, so for example, Sam's house is between S and T. S is the starting point and T is the total point. Yeah, anyway, okay, so we got the Sam's house range. Okay, the apple tree is located at A4 and the orange at B12. There are M apples and N oranges. Okay, apples are thrown apples. No wonder. This array units distance from A. From A. Okay, and the oranges. This array units distance. So 3 minus 2 minus 4. So I have a, I don't know, I have a gut feeling that, so 3 is already positive for orange, so it will already go to the right of the orange tree where Sam does not live. So negative value implies that it's kind of probably going to towards the Sam's house. At least that's how it appears to me. Okay, let's move on. Adding each apple distance to the position of the tree, they land at 4 plus 2, 4 plus 3, 4 plus minus 4. What is happening here? 4 plus 2. Adding each apple distance to the position of the tree. Oh, okay. So we have array of units here, and we have to add it to the tree's distance, which is like 4 here, because it says so. The apple tree is located apple tree is located at A4, and we can then highlight this variables. Okay, so basically 4 plus 2 is equal to 6. 4 plus 3 7. 4 plus minus 4 plus minus 4, so that would be 4 minus 4 0. Okay, 670 is what we got. So we have measured the distance in the apples unit here. Okay. Oranges land at 12 plus 3, all those calculation here. Okay. One apple and two oranges land in the inclusive range 7 to 10. So we print 1 and 2. Wait, what's happening here? Inclusive range 7 to 10. Okay. One apple. How is it one apple? Um, oh. Oh. Yeah. Okay. Okay. So basically, 4 plus 2 is 6. And Sam's house range starts from 7 to 10. So that doesn't really make it to Sam's house. And 4 plus 3 is equal to 7. And this lands on the Sam's house because Sam's house starts from 7 to 10. Ooh, okay. I guess so. And 4 minus 4 0. So it never made it to Sam's place because Sam's range is 7 to 10. Okay, it will be clear with the oranges now. So 12 plus 3 is 15. Does it make it to Sam's region 7 to 10? No. The next one 10? Yes. The next one 8? Yes. So we get 2. I guess so. Makes sense so far. Okay, now here's the thing for function description, and here are the things. I'll just straight get to the right here, and I kind of get the parameters from here, I guess. Okay, S is what was it? Sam's house starts from S, so this is the parameter we get here, and Sam's house ends at T, parameter T, which is integer T. So the next one is A and B. What is this A and B for? A is the, oh, okay, distance of the apple tree, and B is the distance of the orange. Is it so? Explanation here, the first apple falls at position 5 minus 2, that is 3. So 5 minus 2, this is the number of the location of the tree, and we're kind of like adding it up and say the distance of the fruit, basically, if it makes it to Sam's house. And the second one is 5 2 here, 5 and 2, that is 7. It makes it to Sam's place, basically the same calculation that they did it up here, I believe. So 6 and 0. Oh no, it's not the same, but anyway, kind of makes sense. So only one fruit, the second apple, falls within the region between 7 to 11. So we print 1 as our first line of output. Okay, it kind of makes sense. I'm straight going to write the code now. Just want to see the sample. Okay, output format here. Print two integers on two different lines. First integer, number of apples. Second integer, number of oranges. Okay, let's kind of like get on with it. So here we are. So the way out approach is this. First, we need the range of Sam's house. So I won't be writing pseudocode here because it's kind of obvious. So let's get on with it. I'll say Sam starts, that is equal to the first parameter, which is S, and Sam ends. The boundary for Sam's house will be T. It should be something like E or something. Like Sam's house ends E. Okay, and position of the tree. So I'll just say apple tree is the position of A, and orange tree located at B. Okay, we got our variables here. Now we are supposed to what? We need to measure. Are we measuring distance here? Ew, hold on. So we just basically see, oh, we sum it up. Yeah, right. Okay, so all basically do is that count the apples, the oranges, print out on two lines. Okay. Count the apples. So what I'll do is I'm going to like loop over the array of apples here, and I'll basically sum it up with the apple tree from the location. So what I'm planning to do is that, let's write code basically. For each apples as apple, we would do is like count is equal to count. Okay, that would be apple plus uh, app tree, app tree. So I'm counting the distance from the apple to the Sam's house. So the next one would be, what am I supposed to do now? Okay, we got the app count, and now we need to check if, okay, if the app count is greater than Sam's starts, basically Sam's house, and it's somewhere between, and it's less than since Sam ends. And what I want to do is I want to update the Sam's apples. Uh, okay, what do we here? Sam's apples is equal to 0. Oranges as well. Damn it. Oranges. So Sam's apples in the case should be plus plus. And basically what we are doing is we are looping over each of the apples we got, and we are adding it up to the distance of the apple tree. So for instance, if the apple, as it says that they say, let's say that the first input is the Sam's place. Okay, the second one is the distance of the apple tree. So if 5 is the apple tree, the location of the apple tree, so 5 plus minus 2, so that would be 3. So it won't, so the app count is 3 here, and I'm checking that if the app count is greater than Sam starts, so it will be over Sam starts, or basically I'm saying that if the value is between the Sam's house range, basically. If it is, then we'll be adding it up to the Sam's apples here, up here. And oh, okay, I think I'm missing on one thing, which is it said inclusive range. So that should be equal to, greater than or equal to Sam's house. Otherwise, it will always look for over Sam's house and below Sam's house, not the inclusive range. No idea. I haven't tested it out, but I'm going to do the same for oranges basically. And we're going to do oranges. Can we select it like VS Code? Oh, cool. Apple orange. This one should be okay, app. Oops. So, yep, this is the point where I mess it up, and eventually I'll be spending 30 minutes plus hours to fix this bug. It's not up there. Can we do this? Cool. Okay, not cool. I'll fix it. Orange tree, and we saw this one. Let's do orange count. Okay. If this is the case, if orange count is greater than same stars and orange count is less than ends, same ends, okay, print out on two lines what return. Hold on. I'll put print two integers on two different lines. Okay, so that would be Sam's apples. The right way to write it. The break element, I don't remember. Okay, oranges. Let's check it out. Undefined variable. Okay, what? No response on std out again. Different very undefined variable. Apples 10. So it turns out that due to the variable, I had to like spend a lot of time to fix it. So eventually I fix it, and here it goes. So basically my code is absolutely right and it works now. So if we go ahead and give it a test, it works. So basically the logic works. Sam has one by one. We can run again. It's one by one, and we can try out with some custom like input. But before that, I want to show you that as it said the undefined variable here, if we remove this line and run the code, it won't work. Yeah, that's what I was getting here, remember? Yeah, so basically sometimes it happens. So that's the way you have to debug it. And basically, yeah, due to this line, it took so long for me to like really run this code and solve it. So now if I run the code and set, it works. Now let's submit it. Yeah, success. So basically it works. Congratulations, and it worked basically. So I do not have to manually like input some manually put my numbers here. They have already put this test case here. So if we unlock here, see it's not the same, and more unlock this test case for 5 hackers. I don't know how much I have. I don't want to spend it here. So yeah, it worked. So that's how I approach this, and I'd like to do the same with JS. So I'll create another video which I'll be solving it with JS here. So that's it. In case if you have any questions or anything that you want to talk about or how you do it in a different way, please feel free to drop in the comment and let me know what you think about it, how you'd solve it, or if there is any questions. All right, see ya, code on.